This video is going over Priority Standard 5.2, which is talking about equivalent ratios. So your learning target today is I can explain the meaning of equivalent ratios using a recipe as an example. So make sure you fill that out on your learning target under warm-up if you haven't done so already. I can explain the meaning of equivalent ratios. So hopefully you did the warm-up. If you didn't, you can try your best to do it on your own right now. But I'm going to move on to activity number 1. So activity 1 is powdered drink mix. So if you know what a powdered drink mix is, we have Kool-Aid. Another powdered drink mix might be like Crystal Light or some other ones that you may have had before. So we're going to think about this. So it says, let's do a mental taste test. So if I had one of these packets of Crystal Light, on the left, if I put 1 in a cup of water versus putting 4 in a cup of water in diagram B, how would they taste? Would one taste more sweet? Would one taste more watery? Think about it. Okay, so the one that would taste more sweet or way more flavorful, probably way too flavorful, would be diagram B, okay, because we have 4 packets in 1 cup rather than 1 packet in 1 cup of water. So that means they don't have the same ratio. So I would say these are not equivalent. So an equivalent ratio would be a way to make them taste the same. So for example, if I know the ratio here is 1 to 1, 1 packet to 1 cup of water, I could say if I have 4 packets, to have it be equivalent, I would need 4 cups of water. So I would need to add 3 more cups, so I have 4 cups of water, for example. So think of equivalent ratios that way. So we have a diagram where it says, here are diagrams representing 3 mixtures of powdered drink mix and water. So 1 teaspoon of drink mix is 1 white square, and 1 cup of water is 1 blue square. How would the taste of mixture A compare to the taste of mixture B? So mixture A, we have 4 packets to 1 cup of water. Mixture B is also 4 packets to 1 cup of water. So they would taste exactly the same. Because 4 to 1 is equivalent to 4 to 1. Or equal. Okay. So question 2 says, use the diagrams to complete each statement. So we have to come up with some statements about these. So mixture B uses blank cups of water. So mixture B, we know uses 1 cup of water and blank teaspoons of drink mix. So 1, 2, 3, 4 teaspoons of drink mix. The ratio of cups of water, so if we put water first and then drink mix, the ratio would be water is 1 to 4. So the ratio is 1 to 4, not 4 to 1. 1 to 4 is important because it says water first and then drink mix. For question B, mixture C uses blank cups of water and blank teaspoons of drink mix. So we have 2 cups of water, and we have 1, 2, 3, 4, 5, 6, 7, 8 teaspoons of drink mix. The ratio of cups of water, so if we say water first, we got to put the water first, to teaspoons of drink mix. So putting water first, so water is 2, and then to 8. Another way you could write this would be 1 to 4, because I know that is equivalent. If I split it up and I have 1 cup to 4, 1 cup to 4. Question C says, how would the taste of mixture B compare to the taste of mixture C? So I see that mixture A has a ratio of 1 to 4 if I have water to drink mix. This one has 2 to 8. However, I know 2 to 8 is equivalent to 1 to 4 because if I divide 2 by 2 and 8 by 2, I would get the ratio 1 to 4. So it's like an equivalent, it's like an equivalent fraction. So I would say they taste the same because they have an equivalent ratio. So both are using one to 4. So 1 to 4, 1 water to 4 teaspoons of drink mix. 1 water to 4 teaspoons of drink mix. So it was like mixture C is just doubled the recipe, really. D, create another mixture that would taste the same as mixture C. So if I know my ratio is 2 to 8 here, another one that would taste the same, one thing you could do is multiply each by 2. So 2 times 2 is 4, 8 times 2 is 16. So I could say I would put 4 to 16, 4 water to 16 drink mix. And I'm going to say DM. But there are way more, so come up with a couple, at least a couple. You could say, oh, I double that, 8 to 32. Or I could just say, I know it's equivalent to 1 to 4, so I could multiply this by 3 and this by 3, so 3 to 12. There's a lot of equivalent ones, as long as it matches with 1 cup of water to 4 teaspoons of drink mix. Either doubled, tripled, quadrupled, whatever. Activity 2, batches of cookies. This is how it gets good. So batches of cookies are always fun to make. So we're going to read the instructions. So first it says, what does it mean to double a recipe? So if I double a recipe, I times each ingredient really by 2. I times the water, or like the vanilla by 2, the flour by 2, the sugar by 2, every single ingredient by 2. So that's going to kind of help us when we do more problems like this. So it says a recipe for 1 batch of cookies calls for 5 cups of flour and 2 teaspoons of vanilla. Obviously, there's other ingredients, but those are the ones that we're going to focus on right now for our ratio. So it says draw a diagram. Remember, diagram is like a picture, but with just simple picture for math. That shows the amount of flour and vanilla needed for 2 batches of cookies. So for 2, I'm going to multiply each ingredient by 2. So 5 times 2 would give me 10 cups of flour. 2 times 2 would give me 4 teaspoons of vanilla. So I'm going to do 10 cups of flour, and I'll just do my squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm just going to say this is flour. So this is for 2 batches. And 2 times 2 is 4, so I'm going to do 4 vanilla. 1, 2, 3, 4. And I'm doing smaller ones since teaspoons are smaller than cups. Okay. Question 2 says, how many batches can you make with 15 cups of flour and 16 teaspoons of vanilla? So if I know 1 batch is 5 flour to 2 vanilla, I just think, okay, what do I multiply 5 by to get to 15 flour and 6 vanilla? And I know I multiply 5 by 3 to get to 15 flour, and I multiply the vanilla by 3 to get to 6 vanilla. So that means the number I'm multiplying the 1 batch by is the number of batches. So I would say how many batches? 3 batches, because I multiplied each of the ingredients in the 1 batch by 3. Question 3, how much flour and vanilla would you need for 5 batches? So if I take the original recipe, which is 5 flour to 2 vanilla, multiply each of the ingredients by 5. 5 times 5 would give me 25, and 2 times 5 would give me 10. So I'd have 25 cups of flour and 10 teaspoons of vanilla. Question 4, whether the ratio of cups of flour to teaspoons of vanilla is 5 to 2, 10 to 4, 15 to 6, the recipe would make cookies that taste the same. We call these equivalent ratios. So if we do it correctly, an equivalent ratio or a doubled or tripled or quadrupled batch will taste the same. So that's like what an equivalent ratio is. The ratio is equivalent. So we're making all the proportions the same. So question A says, find another ratio of cups of flour to teaspoons of vanilla that is equivalent to these ratios. So you can come up with another one. We've already found out how much for 3 batches and how much for 5 batches. So pick a number, multiply each of the ingredients by the same number for both of the ingredients, and that would be an equivalent ratio. So for example, I might want to multiply each of mine by 4. I'm going to make 4 batches. 5 times 4 is 20, so it'd be 20 cups of flour. And 2 times 4 is 8, so 8 teaspoons of vanilla. I could multiply each of my batches by 10, and have 10 batches, and it would be 50 vanilla and 50 flour and 20 vanilla, etc. Okay. Last one, how many batches can you make using the new ratio of vanilla? So since I multiplied it by 4, then I know that I would make 4 batches of vanilla, or 4 batches of cookies. So if you multiplied it by 10, then it would be 10 batches of cookies. If you multiplied it by 12, then it would be 12 batches of cookies. So make sure you do the right one for the ratio you picked. Then end with the cool down. Make sure you read all the instructions and you answer all of the questions, and then let me check it off before you start on the practice problems.